Here are the answers for the example. S and O, that is a polar bond. N and I, ionic bond. Br and Br, that's the same atom, so it has an electronegativity difference of 0. So that's a nonpolar bond. And C and H, that is also a nonpolar bond. The last type of bond is known as a metallic bond. It's a very mysterious form of attraction. Metals exist in pure solid form at room temperature, but metal atoms don't have enough valence electrons to share and make covalent bonds, and they also don't transfer electrons to other metal atoms. But there has to be some sort of attraction that holds metal atoms together, or they wouldn't be solids. So in 1927, a scientist named Sommerfeld, he described metals as cations being packed into a crystal lattice and held together by delocalized valence electrons. What delocalized means is that the electrons just kind of move around in the crystal and they don't belong to one particular atom. They get dumped into the empty spaces. This is known as the free electron model. Now, the attractive force between oppositely charged cations and the sea of free electrons is what's called a metallic bond. Here's a diagram of the free electron model. So you have cations arranged in rows, and they would dump their extra electrons in the spaces. Because atoms are roughly spherical, you can't pack them perfectly. So there's holes and channels running in between all of those atoms, where the extra electrons are free to move around and flow. Now, if you look at, say, that metal atom, it has a full positive charge, and it's surrounded by multiple full negative charged electrons. That will keep this atom locked in position, which means it can't move very much, so it's lost kinetic energy. Now, a good analogy for a metal crystal is a Rice Krispie square, where the positive cations are your Rice Krispies and the negative electrons are a sticky, marshmallowy negative glue. When you make a metallic bond, you can get between 75 and 1,000 kilojoules of energy released. So we say it's roughly the same strength as a covalent bond, depending on which metal you have. The strength of the bond depends on two things. The smaller the metal cation, the stronger the bond. But also, the more electrons in the sea, the stronger the metallic bond.